Okay. Let's make sure everything's working. And then after that, we can get started. So let's check YouTube. Perfect. And then Twitch. Test. Perfect. Okay. God, love that low latency. Okay, so anyways, where were we? We were at here. So, I did some thinking. And we're between a rock and a hard place. But I'm trying to figure out how to thread this snake. And then once we do, I need to start coding. We're off to the races. So here's the issue. If we do... So we theorized, what happens if we do the cross-agent calculation? This was where we looked at each enemy's actions and all of their permutations, and then we assigned those permutations. Basically, like, each permutation was a world state. And the issue with this is that it is a highly exponential function. So if we have 3 enemies going at once, our numbers get incredibly large, and we can just scale that up until absurd things at every depth. So that doesn't work. That's too lazy of a solution. It's not going to be good enough. So then I thought about doing the pseudo-legal calc. Now, the issue with doing pseudo-legal calculations... Oh, to be clear, this is where each agent considers their actions separately, and then whenever we get to the actual go time, we check to make sure their action is still valid and make sure they don't conflict with each other, and then we have them perform those actions. The issue with this is that the... how to put it? The pseudo-legal doesn't work because, like, here's an example, okay? Let's imagine that we have a hallway. Let's imagine it's a very narrow hallway for a point of illustration. So we'll set, these are our walls, right? And then we'll have the player be here, and we'll have enemy 1 be here. Now let's imagine that the boss is here. When the boss goes to conceptualize its turns independent of the zombie, then it has a hard time realizing that it has a hard time conceptualizing of the idea that the enemy is not immovable. Or actually, let's change this slightly so it's even clearer. Let's imagine it's a 3-wide hallway. So let's say we have this. The boss is going to try to walk past the enemy to go attack the player. So let's imagine that the boss plans a route here and a route here, right? Hypothetically. Let's say that the enemy moves left. And we go, okay, cool. The boss is now just going to account for this by heading right instead. Well, now we end up in this weird world where the boss should just move forward. But now they're still bending right because that's still it's still conceptualized a world state where the enemy was still in the way whenever it went to do the calculation. And the issue is that if we ignore the enemy and we create the world irregardless of them, then we end up in this weird situation where... oh, fuck, am I in insert mode? Yeah, weird. Okay, I don't know why I was in insert mode. We end up in this weird situation where the boss will now try to move through the enemy, and it doesn't really have a reason to conceptualize a world where it also did these. Granted, I guess it could, but then we significantly increase our world states that we have to check, because now when we can't like flatten this ever, right? We have to keep all of these combinations open at all times in case that the enemy ever floods it, which I guess we could do. That's option one. Option one is just ignore all enemies and do calc, do pseudo legal. I feel like it's going to cause really weird edge cases though, where you'll end up in situations where enemies will ignore each other for the sake of doing something, and it will fucking destroy the encounter and cause a bunch of mayhem. So I don't really like this idea. Especially because if we go back to this narrow example with the 1x1s, or the one width, I feel like what would happen is the boss would ignore the enemy, plan all of its moves to go in, and then have like 1 or 2 shitty moves to back up or whatever. And then when it gets to the end, it's going to like, I don't know. Maybe it could work. It might work. It's possible, okay? It's possible. That might be what we have to do. So I'm not going to completely rule it out. I just hate the idea. It just bothers me. So then we have a third option, or maybe multiple. There has to be some way to do like sub-variations. Where when enemies... one huge thing that ignoring enemies does increase the complications for is state machine checks. So, like, imagine that we're in the narrow 1x3 or whatever, and imagine that the enemies... Let's imagine, for the sake of argument, that enemies block line of sight, or that the enemy is like a massive gargoyle that is defined as like a wall in terms of blocking line of sight. Well, if the boss ignores the enemy, they now become aware of the player. And we have to then conceptualize a world state. We would then have to, at every step, make a new variation for a change in world state. Do you understand? Because, like, now... Because now, not only do we know the world state, we'd also have to consider a world where we didn't know the world state at every time step. And it would have to be a combination of all of our possible world states, because it would drastically complicate shit. We can also do... so yeah, that's another big issue with that. And then the next thing is some combination where, like, if you're alone hunting for the player, only have to think about yourself. You're easy. But if you're, like, in combat with 2 enemies and the player, then you do have to consider your 3-person mesh of interactions. But, I don't know, like, even if we had 3, right? Like, so imagine we have 3, and imagine that our action count is, let's say, 7 on average, 6, well, let's say legal moves. So we'll say 3 legal actions at a time, 4 legal actions. And then we'll set directions as at most 8. L and M don't matter right now. So then if we go into cross-agent calc, we end up with 512 world states. Just at depth 1. By the time we hit depth 2, it's 10 to the 7, which I want to say is that 10,000? What is 10 to the 7? 10 to the 7. 100,000? No, that's 10 million. That's 10 million world states by depth 2. Oh, fuck me. 1 second. I also thought about ways to potentially simplify this, because technically we're considering maximums, right? Granted, I think maximums are really important here, but maximums are going to scale more exponentially. So what I did is I ran an individual case calc. So I considered, like, what are a set of moves I could give a zombie, and then, because the zombie's a pretty basic enemy, and then what would that look like? So I made a set of actions. We have a basic walk, so it's 8 possible directions, which means that there is A was how many enemies this would affect. So this was the idea of, like, basically for storage, tracking how many enemies you're changing. So this is 8 directions. It only would affect itself. Then we have, which might not even be true technically, because if you block an enemy, then you are going to be affecting its potential state or whatever. But besides the fact, then we have 3 directions for, like, a swing attack, because you'd only want to be able to swing if the player's in your arm reach. So there's only going to be up to 3 tiles where that'll be the case. We have a bite, that's going to affect you and the enemy. Then we have a, like, lunge, so it's just like a sped up walk in some way. And then we have a, like, feed, so, like, if it's over a corpse, right? We could also technically add, like, a smell or something along those lines here. That would be fine as well. So what I did is I made these actions, and then in the individual test case, I basically tried to imagine calculating, because the base calculation I have for pseudocalc is number of enemies times the number of directions times the number of actions. That's what the calc is. So I'm basically trying to swap out DN for this test case, and then A is going to be 1 in this case because there's only going to be 1 enemy, which comes out to LA. Let me change LA back to 1 for this because it should be that. And we end up with that zombie will produce up to 63 legal moves. So that's assuming, in this hypothetical, that you could move 1 in every direction, or swing at the player, or bite the player, or lunge at the player, or chew on a body all simultaneously. Which isn't technically true, because there's not that much overlap. But there's going to be some, but there's worlds where that's not going to be the case. But assuming it is, we can imagine up to 63 possible calculations per step. So by depth 3, this single enemy produces 250,000 variations. So what I'm getting at is, I don't think that this solution path is viable. That's the crux of what I'm getting to. I don't think it's possible. Because just with a basic bitch enemy, we produce so many world states. It's like if instead of calculating like a chess engine, we're calculating like 7 chessboards simultaneously running. Like, it's fucking insane. This is just way too much. So, we need a solution. So that's what I'm trying to figure out. That's what today is. Today is trying to figure out what can we take from this and what can't we. Because we might have to hybridize it in some way. But I'm okay with some level of hybridization. I thought about the idea of combining it, where like sometimes they're cross each other, and then other times it's individual. But I don't know if that's really going to work, because we still have the issue with this individual case eating up a lot. I also thought about the fact that if we do this emotion-based state thing, where like different motivations shape the weights, we might be able to attach each action to an emotion, and then that should drop the number of actions that could be calculated. So like, an enemy who's in the anger mode, who just wants to fucking kill the player, they're never going to stop and chew on a corpse. That's never happening. They're going to hunt the player, they're going to find the player and fight, they're going to fight the player. There's never a point where like it'll stop and be like, oh, time to eat something. That's just never happening. So we would, in like the anger thing, we could just cross off that one from the list. or in like an aggressive style, like we might hardcore drop or like limit the this was another idea I had. We could hardcore limit or de-weight in action so much that we eliminate it from our check, basically. Like if you're in melee combat with the player, when you go to conceptualize all the directions you could walk, if it makes you leave melee and you want to be in melee, then like we would have to have a really good reason to pull you out of that, if that makes sense. But fuck. Then the issue is that we would then still have to keep track of those world states irregardless, because if something unexpected happens, then we're fucked. You know, if the trap comes rolling down the hallway, big boulder, Indiana Jones style, then the enemy has to be able to at least conceptualize a world state where it did back up. Fuck. I think there's two routes that we can take to do this. In one route, we make the world much more deterministic. That's route one. So for right now, I have guaranteed the use of non-randomized or of randomized number output. And what I mean by that is, like, if you swing the sword, it's not going to do d6 damage. It will always do 2 or 4 damage. So, like, and you'll always hit. There's not, like, a hit chance. So I've just removed that entirely from the picture. One, because I don't think it fits the horror environment as well. And two, because we have a lack of UI. That would be an additional layer of complication that we'd have to keep the player up to date on, which I just really don't want to do. So, yeah. And then also you introduce so much more balancing and randomization and shit you have to deal with. I would rather keep that much flatter. So, then we have... So we removed that level of randomization. We made that more deterministic. I feel like in order to make this world states very deterministic, in some regards, we would have to track that was the original point of the cross agent, right? Was pure determinism. The agents know not only every option of what each other could do, but every option of what the player could do, such that we could never enter a world state where we're not accounting for it. That was the whole idea. But now we have a problem. Because the cross agent is just too fucking expensive. You know what? Okay. This is going to be time consuming as fuck. So, if you hate this, skip ahead like 40 minutes or some shit. But what I'm going to do is I'm going to plot out a round of combat. And I want to see how many world states I produce. For this hypothetical, we're going to have 2 skeletons, we'll call them, because zombies are going to be slower than the player. So we'll have 2 skeletons or something along those lines. Spawn, maybe. We have 2 spawn. One has speed 7. The other has speed 6. player has speed 5. So this means that enemy 1 is going to get 3 turns, and enemy 2 is going to get 2 turns. Okay. So when we go to, if we were to do the cross combination, and we'll say that they have the exact abilities that the zombies have for point of reference. So enemy 1 will consider, and let's draw our starting map is going to be, we'll make it a 4x4 room. So it's a 5 for the walls. There we go. There's our room, and then we're going to imagine that we'll put the player here. We'll put enemy 1 here. We'll put enemy 2 here. Okay. Let's see where this goes. So enemy 1 is going to conceptualize of a move in all directions. So that's 8 world states. Oh no, 7. You can't move on top of the player. 7 world states. For point of, let's say that the charge isn't possible. Oh, and for the emotional moods, because I want to kind of see if we could limit them, let's put both of them at hunger. So they're fucking aggro as fuck. They want to kill the player and feed on its corpse. So we'll put them both, they are both hungry. Okay. So 1 considers a move in all 7 directions that it can move into. It considers a claw in 3 directions, which is going to be -1, 0, so 1 to the left, -1, -1, so that's the direct diagonal, and 0, 1, the direct up. And then we'll say that there is and that'll produce 7. We'll do dashes for the amount of possibilities. That way I can keep those distinct. Okay. Then we have 1 bite. Then we're going to have 8 charges. Now for this, I think since it's already in melee, we'll just completely disqualify the charges. And then we'll do corpse eating, no corpse around, so it can't do that. So in this first world state, we produce 11 possibilities. Okay. Now, let's step through world state 1. We'll weight these, and so, or heuristic them. And so the most preferred in order is going to be claw. No, we'll do bite, claw direct, so claw -1, -1, and then claw, it'd probably be random, so -1, 0 between the two. I don't know if it would have a preference between those two, or I hope not. Okay, so those are the 3 that it has a preference between. Then we would hit, then we'd get to the next one, so we're like, okay, we've done the quote-unquote first turn, that was the bite. So now, E1 and E2 are going to plan, acknowledging that the previous turn was bite in this case. So now we're entering the depth 2 of the search. And for this, let me make a new folder. And we're going to call this multi-test case. Let's start with a table. And we're going to set this at, yeah, we'll say x of, we'll put x, and then we'll set this to worlds for w. So we end up with x as 1, we have 11 world states. Okay, We'll see where we end up with 2. Okay, so then we go to do 2. And, so if we did the bite... Oh, let me make sure that, fucking paranoid that my tabs aren't showing up properly, so I'm just constantly rechecking them. Okay. Let's put you there, and then we'll put you over it, and then we'll close that, and then, okay. We'll go back here. So now let's imagine off the bite. So we choose the bite for now. We're depth 2. So now we're going to build around the bite. So nothing, the offset in this case, so stored offset is stamina burn and then damage to the player. Okay. Now we go to number 2. So now we're going to do the same thing again. Let's say that we'll put a... normally, we would probably put a cooldown on bite, but let's say that in this case, if the cooldown would normally be like 2 turns or 3 turns, let's reduce that cooldown by 1 because they're in... because he's in hunger mode. So we'll say he can't bite this turn, but he can bite next turn, we'll say. So when we go to the devaluation, bite's off the table now. So everything was identical except for the fact that now move and claw. So we have 7 combat, or 1 has move and 7. Why is it dotting it? Okay, there we go. I don't know why I did that. And then we have 1 claw and 3. Okay. Now, that's not how we're storing this. We also need to consider it's going to be 2 has move in 3 directions. 2 has claw in 0. 2 has bite in 0. 2 has claws off the table, bite is off the table. It sees the player, so and it doesn't have a corpse to feed. So yeah, we just have move in 3. So now what we're going to do is we're going to cross combine these. So for each of them, we're going to combine them. So we have, oh god, hold on, let's do this math real quick. So it's going to be, agents is 2, N is going to be, D and N are going to combine out to, what it'll actually be is, I think D and N in this case would come out to the total combined multiplied value between these. Because this is the number of actions times the number of directions. So in this case, I think those would be 7 times 3 times 3. Or no, it wouldn't. It's 7 plus 3 plus 3, because we're conceptualizing the number of possible actions you can commit. Oh, but the formula is wrong here, because instead of conceptualizing maximums, we're trying to conceptualize the target number. So it's not going to be the number of possible actions to the number of agents, because then that would assume that each agent can do that many actions, but each agent can't do that many actions. So it's a different formula now. Okay, so instead what we'll do is we'll do 1M, 1C, 2M sub 1. 1M, 1C, 2m sub 2, 1m, 1c, 2m sub 3. So that'll be 7 variations of that. 2m 1 through 7. So that's 7 so that's 7 variations. So it'll be 1m 1c1. Or no, 1c1 doesn't need to be here. We'll just conceptualize the moves first. So that's that, and then it'll be 1m. Then you'll need to multiply that by. So it'll be for 2. And then, okay, so it'll be that, and then we have to conceptualize 1 for each of the claw. So it'll be 2c, 1 through 3. So that's 3. And then it'll be 1m2. So I think it'll produce 10 world states at each move. Because you'll have to conceptualize the move at 3, and then the claw at 7, and then the move at, move at 3, claw at 3 per. So if that's 1, that'll be 3 each, it'll be 9 total, and then it's to the, yeah, so I think this is 30. Let me double check just to make sure. 1 move, 2, 2m, 1 through 7, 1m2, 2c, 1 through 3, 1m3, 2m, 1 through 7, 1m3, 2m, or no, 2c, 1 through 3. So yeah, I think that's a total of 30 actions. So we produce 30 actions here at world state, at depth, just for this is 30 inside of the first of 11, should be what that says. So the way we could figure this out is we combine the number of actions one agent can do and the number of actions another agent can do, and then we multiply those numbers. That's how we get that. Okay. So now we can simplify this moving forward. So we're going to do that. Let's say we're going to go to depth 3. I want to go to depth 3 for this. So what we'll do is we'll actually, we'll change this. We'll do 2 sub 1. Or maybe 2.1. I don't know. I'll just write it down for now. For 2.1 we have 30. We'll add it up all at the end. Okay, so then we go to the same thing. So that's for byte. Then we're going to go to inside of byte. The best move inside of byte is going to be they're going to go simultaneously. So if they go simultaneously, what we'll do is we'll do them in order of ID number. So it's, oh fuck, hold on. When 2 enemies have the exact same tier and speed, then I guess the next thing would be ID number, but you'd have to know that ahead of time because you're trying to evaluate if the claw goes after, then it might end up hitting the buddy, who's now going to try to 2's best move is definitely move diagonally or move left easily towards the player. And then 1's best move is going to be a claw attack. And so if the 2 moves down to the bottom left, the 1 would probably... Okay, but here's the thing. Does 1 actually care to prevent that? Even if it knew, I don't know if it would care. Let's say it doesn't matter. Fuck it. You know what? We'll say it actually moves first. We'll say in this system, here's an assumption. Moves always go first, then blocks, if that's a thing, and then attacks. Or actually, let's not go over it. We'll just do attacks. We'll write it out as we go. So it'll be moves, then attacks. Okay. So now that we did that, now we're going to conceptualize after we do move neg1. Oh, this should have been neg1 pos 1. Yeah, so it'll move neg1, and then it will and then we'll have claw neg1 pos 1. There we go. That'll be our chosen move for depth 3 inside of this branch. And so now we end up with, in this hypothetical, let's copy this real quick just to see our current world state compared to original. Why does it keep putting me back in insert mode? Okay. There we go. So now we have world at depth 2. A solution is going to be, we're going to do this all over again. 1 has 6 moves. 1 has bite back, so there's bite again. 1 has claw 3. Let's not complicate this. Let's say they're too hungry, they're not even paying attention to each other, okay? They don't even consider the fact that they're gonna get each other fucking beat the fuck out of. So they're not even pissed at each other enough to fight each other over you. They just want to eat you. So I think that's everything. Oh, and then the stored offset is stamp burn, damage to player, and 2 CD back on bite for 1. Okay. So 1 can do these, and 2 can do move 6 as well. 2 has bite now on the line, and 2 has claw 3 as well. So in this total combination, each agent can do 7, 10 actions. So it's going to be 100 combinations then. So now we'll make a new one. We'll call this 3.1, and we'll make this 100. So we'll put the right number as the branch for this. Okay. And this will be 1, actually. We wanted to say we were going to go to depth 3. I believe the next world state that we would have checked is going to be well, hold on. We will actually have 3.12 and 3.13 will also be 100, because each of those world states would have been player moves, 2 still moves here, and 1 did one of 3 claw attacks, right? Each of those would produce the exact same result, or no, slightly different results. It would 2 of them would produce the same world state, where both player and enemy got hurt. 1 would produce a unique world state where only the player got hit, and that was if we swung directly left and missed 2 on top. So there would actually be 2 unique world states there. So yeah, we'll have 0.11 is going to be 0.11 is going to be Claude P and 2. 0.12 is Claude P P to move neg 1, or neg 1, plot P and to, no, plot P to move neg 1, neg 1. Then we have the exact same set of actions, except, you know what, we'll keep it inside of the actions. So next would be 2 still moves down here, but now 1 is going to do all of its moves. So there would be oh, wait. Hold on. I was wrong. Instead of having 30, we would have 29. Because, if assuming we're doing this deterministically, there would be one world state that would be canceled out, where 1 and 2 would try to move to the same tile. So that world state's gone. I forgot to include that world state. Or to remove that world state. That hasn't affected anything yet. But, because back here was our start, where the player did the claw, and then what would happen is now we're going to conceptualize if the enemy still went down, but now the player went, or the one went left. Yeah, so I guess the math isn't 2 to the... What did I write for this? Because this was trying to conceptualize all the legal moves. So instead of it being D into the A, that's the worst case scenario. 0.53 D into the A was trying to minimize it somewhat. But actually, if we look at this, by the time we hit depth 3, what was the legal actions at each stage? Because this is the hypothetical max legal actions. This is what we would have assumed we could do at every step. And then if we had halved it, so it would have been 8, 11, 12, 21 possible moves. But now, the first one, it could do 11. When only 1 was going. And then the second one, we conceptualized 29 worlds. And that would have been, if we had done that in here, this would have been 21 to the 2. Which would have been 441. So that would have been way overzealous in terms of how many world states we actually produced. Maybe we actually can do the cross-calc, and that my worst-case scenario math is just too extreme. Because if we can conceptualize this, 1 is basically always only allowed to move 6 legal moves, while in these 2 positions. And then would it be down here? It would be 5, and then here it would be 3. That would be 4, and you'd also lose all of your attacks. Your most expensive options are going to be right here when they're both in melee with him, and then you're going to produce. So let's see. This would have been anytime the enemy's in melee, where they're both in melee, it's 100. So that would have still been true here. Would lose truth if the player moves down. here. Then your options drop to 5 times 10, which is 50. If the player or if one, I keep saying the player, that would also be 50, but that's still a unique world state. That'd be 3 times 10, that's 30. And then, here we have 1, 2, 3, 4. So that'd be 40. So for our, and I think that's all of the sub 3s. Oh no, you also have to conceptualize this one. 1, 2, 3, 4. That's another 40. So we have 1 in all 6 directions. 1, 2, 3, 4, 5, 6. 2 of the claw attacks would produce the same outcome. And then 1 of them. So let me hold on. Description. We're gonna write that. And then we're gonna just put D, I guess. Okay. We'll put D1. There you go. So this would be bite here. We would choose bite. Here we would have chosen claw. And then this would have been well, actually, we don't have to consider the points here. That's not the point. The point is just to consider the... Oh no, this would have... Sorry. The first one is just how many... Oh, we don't choose yet. Here we would have chosen bite. Here we would have chosen claw, comma... claw, comma, neg 1, neg 1. That's how we would have done this. There. And then that would have also been true here, but it would have missed 2. And then this would have been, these would all have been move options. And then I don't think we would have been able to do bite here anymore. So this is all of 2.1. All the possible variations of sub 2.1 into depth 3 would be that, and then we would do something similar here. We'd go 2.2. And 2.2 would be if you did the same claw, and now neg 1, 0 would be the next world state we'd check. So now it would be identical. Like you'd do 2.21 would be wait, I think I did this wrong. Fuck, hold on. I gotta go AFK real quick. Give me a second. Oh, hold on. Let me turn it to let me turn this off so that you can see Dave K. Be right back. All right. Sorry about that. Where were we? That's right. We were calculating out a practical example. So the next world state was this one. And so our move combination is going to be one can move in 7, one can bite 1, one can claw 3, 2 can move 1, 2, 3, 4, 5 spaces. No, 4 spaces. 2 can bite 1, 2 can claw 3. Then we can imagine sorry, hold on, I blinked for a second. Okay. So we were trying to conceptualize how many world states this would become. Wait. Hold on, I think I'm doing something wrong here. Okay, so this would be a total of 9. This would be 81 world states. Minus 2 down to 79 because there's 2 worlds where they bump into each other here. And that won't work. But I guess we would... Would we check conflicts We'd have to check conflicts in runtime, right? I feel like we. No, we'd have to check it beforehand because otherwise we're going to generate out so many invalid turns. Unless we only checked our legal actions and then in runtime we check the invalid, like the ones where we'd cause conflict. But I feel like you'd waste so much memory if you did that. Maybe you wouldn't. Maybe it's better time wise to not calculate out what it would actually cause. Or maybe you only do it once you start considering further into it, and so if it contains a interruption, then you back out one. But let's say that it produced so but that produces 79 world states. Okay, this would be 79. And that would be byte, comma byte, wait, maybe once you choose this, or no, it should be this. So we had 11 combinations. We chose byte, so now we end up with 29 combinations off of the byte. Then from there, how do we get to 29? Because you would still have 10 move options. Oh, times 3 minus the one where they overlap and bump into each other. Or no, it would be minus 2, because theoretically they could also move to this space. So it should be 28 world states. Once we've chosen byte, and then I guess we could do it this way as well. Just you chose byte at this world state, then we choose claw, then these are all the consequences of claw. Down to here would be claw minus 1, O, minus 1, minus 1. So this would be basically identical. These would not be identical world states. So if we had to concern ourselves with stamina or something, then they would be they would have to be calculated distinctly. But unless they Sorry, I'm zoning out and fuck. I can't. Hold on. I'm zoning out. 1 second. Okay, so this is where we chose to do a bite. That's where we chose to do a claw attack. This is where we chose to do another claw attack, but we missed the player because the world state of claw -1/1 is identical to the world state of 0/1, so we could collapse those actually. So these would be identical. So we would treat this as okay, and this would have been that claw attack, and this would have produced so I think we had done this instead. That was this one, I think. 7 moves, 1 bite, 3 claw. 4 moves, 1 bite, 3 claw, which comes out to 10 times 8, so 80 moves possible from here. Minus the 2 overlapping walk checks, assuming that we did that, so it'd be 78. Or no, this is 11. This would be 88. Minus 2 be 86. Fuck me, I can't do math. And then we'd have 2.21, which would be all of our variations off of this, etc. I think when I wrote these numbers, I think these were not supposed to be marked as 3. Because 3 would have been the depth, and that's wrong. God, I wish I was better at doing this. Like, if I had moved here, then, and he had slashed, it would have been this many. Hold on, I'm deleting these columns. I did something wrong here. yeah, now we're in the second world state where we did a bite. And then 2.1 would have been the chosen action of that. 2.2 would be that. 2.3. And we'll do it this way where we'll make Agent 2's action the second thing, or the first thing. So that way we can do it this way. And the reason that matters is now we can label these 2.11, 2.12, yeah, 2.13. So now that this is move down here and move up here, one can now do 1, 2, 3, 4 actions, and P2 should still be able to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 attacks. So at 10 here, that would be 40 actions minus 4 for movement overlaps. So 36. Three, 4, 5, 6 actions. Still 10 up there. So that would still be 60 minus the 1 overlapping move action, so 59. These are different world states, but these two down here will have the exact same number of actions, which will be 1, 2, 3, 4, 5 with, or no, actually we'll have different numbers, off by 1. This one will be 50 minus 2 for the overlapping movements of 48. And this one will be the exact same thing, but it'll actually be 47 because they have 3 movement overlaps now. Moving into the bottom corner gives us 3, so that would be 30, with 2 overlap actions drops us down to 28. Moving over here gives us 1, 2, 3, 4 actions. Which is then going to be 40 minus the 2 overlapping moves down to 38. I think that's all 6 move combinations. Which was only possible for if he had moved down here. And I think that's everything. I should actually probably... Fuck, hold on. Is there a way to insert a new one here? Yeah, okay. Let me change this down by 1. So I'm now going to confuse myself if I keep this and make 2.12 the there. They would be flattened into 1 technically. Well, I guess if they were going to be flattened into 1, we shouldn't notate them separately, should we? And I'm going to undo it right after I did it, like a dumbass. Okay, so 1 for the bite, or 1 for 1 claw, 1 for the other 2 claws, 1 for all the 6 moves. It wasn't allowed to do a bite at this stage, so that's correct. So at this point, what is our amount of world states? We have 2 other player actions to go through, but our next steps would contain 28 plus 86 plus 36, 59, 48, 47, 28, and 38. Okay, so far we're at 370, which means we'd hit... we won't hit 1,000 because other ones won't contain as many world states. Technically, we're missing a few here, I just realized, because we didn't conceptualize the idea of them just standing still. That should always be 1 more action possible, so that's going to inflate our numbers a little bit. But if the player moves down here, they're only going to be able to move like 5 spaces, so we've cut out a good bit there. And then if the player moved up here, it's almost identical, so I think we're going to end up with about 800, I think. But if we had calculated this, A equals 2, our number of actions were 3, move, claw, and bite, right? That's our 3. And our directions are 8. We would end up with 72 world states at start. We're at 11. Then we would have hit 41,000. We're going to be about 800. I won't hold the first one against it because it isn't conceptualizing the fact that only 1 person's going to go. So if we ignore that, we still end up about... we still end up with way more world states. If we end up doing... so that was, well, fuck, hold on. We were at 370. So it would be about 800. Oh, that's why. I was like, why is this number bigger than that one? Because technically we would then consider the 800 something equivalent to x is 1, but we don't because we're starting with the preposition of starting out of this from 800 actions. So, if we back up a second, what we could do is we could just look at how many actions the combination of these would produce, which has been about 50 or 60, give or take. So we're still short, so it'd actually be closer to something like 50 or 60 divided by 72. Let's go with 55 just to be safe. 55 divided by 72, which is about 0.76. And then that leads into about, what, 800 divided by 41472, which is about a fifth. Okay. Here's what we're gonna do. We're gonna try it. We're gonna try doing the let's just do cross agent and see how many world states we actually produce. I kind of want to see what that number is. I think one thing that will help. I don't know if I want to say that. This still gets really scary with a large number of acting enemies. Like, it gets pretty hefty. But let's see where this goes. And then we'll kind of gauge it from there. All right, let's actually start coding. Why don't we? I think I at least want to try it, okay? We're at least going to see what this looks like. Okay, so let's go into, like, turn off your abilities to the Chrome so you can only see the code, and then that should fix that. And then I wanted to do one last thing I want to check. I'll check this real quick, and then I can just tell you the results. I wanted to calculate out how much memory this would equate to. So if we assume that the max was around 800 or so world states for that depth, then we could say 800 times, what would this be? Each world state contains 8 bytes plus 1 to 3 offsets. So we'll say an average of, most of those were moves, so maybe like 1.4 on average. No, wait, fuck. Divided by 1.4, I did that dumb. It should be 800. 1.4 is going to be about how many offsets. Each offset is 4 bytes. So it's going to be 8 times 1.4 plus 4 times 800. 8 times 1.4 plus 4 times 800. Okay, that's about 12 kilobytes, give or take. That's pretty expensive. Okay. Here's what I feel like. We've been working pretty hard to keep the data small. If there was one place that we would expect to see a large use case of data and a large use of memory, it would be in our AI system. So if our AI system ends up taking up a gig or two, I wouldn't be happy about it. But if that's like that should be an okay baseline. Because if that's like, a third half of our memory consumption in the course of playing the game, then I think that'll be an okay position to be at. If it ends up being as much of a weight as I expect it to be. Because our tiles are pretty small right now. So I think that'll be fine. Real quick, I needed to check. Oh, map data. I wanted to change a few things. So I thought about this. I don't think I need his border. I don't even know if I need his region edge. I do need his dynamic. So I'll keep that. What I was going to do is I was going to create, I think I actually need to make a... Can you turn this into a... Hold on real quick before I forget this. I'm going to run gen system. Pull this up over here. Am I able to save this as a byte? And then if I change this to a byte, cannot apply or equals of type byte and enum. How to use a, what is this called? A bit flag? C# enum flags. And then we're gonna I'm trying to see if there's a way to apply this on top of numbers or if you have to store this as the enum. So I would expect you to just be able to check the flags against the number. For int val is equal to 0, val is less than or equal to 16, val plus plus. Single hue. Oh, you just cast it into the thing. Okay. The assignment target must be in a variable property or indexer. Well, it is an indexer. It's a That is, it is literally an indexer. TCS is a array. Okay, why is it not letting me call this? Cannot resolve symbol get tile? What? I have map data. What the fuck is the issue? I don't understand. Hold on. Cannot resolve. Map data has. Oh, it needs to be dot value RO. I'm fucking stupid. Assignment is type int, not uint. Okay, yeah, I should probably change that. Oh, wait, no, fuck, this doesn't work. Hold on. No, I do want to keep that. Get rid of the ints. Over here, this doesn't work because we're not referencing the built map yet. We need to be referencing the temp map. Maybe change it, make a get index function that it also pulls, but that's not, fuck that. We'll just do it this way. The assignment must be an assignable variable property or indexer. I guess there's no real issue with storing it as a... No, this should be an int anyways. Of storing it as a tile property. So I think I want to create... The issue is that there are multiple types of things. So I originally was going to have it is wall or is floor, but the issue is that there's is wall, is floor, and like is pit. So now we have like 3 possible environmental types that could be there. So what I would like to do is, I think if I create like a sub enum basically of 3 bytes, then that would work. And then the other thing is, I don't think I need is border to check, because this border was supposed to stop you from accessing something outside of the array. But I don't think I have to worry about that because I can just, I can make sure that it's not allowing me to access it basically if I Or I can just check to make sure that I can't call it before I do the get tile. So I'll just be like, if indexes, right here, we'll just make a function called like public bool can get tile int x int y return x is greater than 0 and x is less than map underscore x underscore length and x is greater, or y is greater than 0 something like that. But anyways, is empty, is dynamic. Let's do a let's say is dynamic to max, or to up here. So we'll set that up to, what is that? 1, 2, 4, 8, 16, 32, 64, 128. And then we'll set we'll have is wall, is floor, so if we have these 3 bytes, or no, it would be 2 bytes. We're storing 2 bytes for this. So is wall would be 01. That's fine. Is floor is going to be equal to 00. Fuck. Do we need 3 for this? Is wall or is floor or is pit? We make like a 4 combination thing here. And the 4 combinations, but we have to have at least 1. Because if you have just 0, yeah, fuck. So it'll actually be 01, 10, or 11, or 11. So we'll set wall is going to be 10. That'll be 01. What does that come out to? One, 2, 4, 8, 16, 32. This one's now 64. And then we'll have is pit or is hollow, something like that, which will be equal to 0110, which will be 32 plus 64 in this case, which would be 96. Now we have 5 bits left that we can play with on the tile, but that's fine for now. For now, all we're going to do is we're going to set it to a wall. We'll replace this with is wall. And then we don't need region edge. We could actually probably delete this whole section. Recompile real quick just to make sure that works before we continue on. Behavior system data. Burst error, burst error, burst error. Okay, don't care. Click play. Correct. Good. This is exactly what I wanted. Okay. Let's shrink the map a little bit for now. Where was that? One generation system. Set it to a 5x, or no, we'll do a 7x7. And then let's do this. Okay. So when we go to plan an enemy turn, what would be the order of events here for true deterministic fashion? That's what the issue was. Okay, it's the bracket. So we're going to create a buffer of world states. Good. Then we need to, I don't care about getting total memory right now. Although, we should probably, we should probably see how much memory we're actually going to end up taking up. Okay, and then what we're going to do is let's get a collection of all the enemies that are going to go for the next player's turn. Let's just calculate out the next turn that's going to happen. So we're going to start on let's check our, what do we have? We have our ID sorted by speed. Okay, and we're gonna make a collection, so we're going to say we'll say unsafe list, or no, unsafe list of type byte for IDs, sorted enemies. Okay. For this, if IDs sorted by speed, bracket I is equal to 0, break. Let's make a equals new. Okay. Then what we're going to do is sorted enemies bracket I, or no, dot add no resize I. Okay, fuck, hold on. Let's back out. So the first thing we do is we get a list of enemies going before next player. Get a list of available actions. Combine all actions into a pool. Final actions into a pool. Sorry, I was trying to figure out a way I was going to be able to combine them, but I think I have an idea. Combine all actions into a pool, and then into a pool of world states. Sort world states by heuristic. Begin next depth. First, confirm world state is valid. Doesn't cause conflict. Combine all sub action or get hash map of available actions. Reuse question mark. Combine all actions into a pool of world states. Sort world states by heuristic. Oh, wait, no, this needs to get a list of enemies going next. Oh, fuck me. I need to get used to this control scheme. Next tick. That's what needs to happen. Yeah, so we get a list of enemies going before the next tick. Then we get a hash map of their available actions at this current point. Probably by feeding in the default world. But I would assume we can probably create... yeah, we'll make a... just make a list of available actions, and then we'll start at the world states. Okay. Then we sort the world states by the heuristic, and then if at depth val a return or return back to continue recursion. Okay. Fuck. Here we go. Gales of enemies going next tick. Should be simple enough. We'll just do a for and I is equal to 0. I is less than bsd.value.ro dot turns to take this round. Or no, the ID sorted by speed. Dot length. I plus plus. If bsd.value.ro.id is sorted by speed bracket I is equal to 0, break otherwise. Oh, here's what we do. Okay. We actually need to start with the current one. Okay, otherwise we're going to set new, or no, aspite cur max turn, or no, it would be cur turn is equal to bsd.value.ro.id sorted by speed, bracket 0, but we actually don't want this. Fuck, hold on. We're going to make a new one. We're going to call this byte first ID is equal to then we're going to start off at 1, and if it's equal to 0, break, and otherwise, if it's equal to 0, or I think that's right. So what do we do? First we create the list called enemies next tick. Oh, we need to add it. Otherwise, enemies next tick dot add no resize ID. Why is this one not happy? Oh, not current chart. This needs to be first ID. Okay, so we get the first ID. If it's the player, we throw an error because we don't know how to handle that yet. And then if it's not, we check to see if it's the current round, or how many current rounds it's supposed to take this turn. And we set that as our max turn amount that we're taking. So we're just trying to figure out who's next, what the next bucket of enemies going is. Then we add the first enemy. And then we start off one past the first enemy, and we iterate through until we either find the player or we find... well, actually, it doesn't matter if we find the player, because the player will always start off the speed of whatever it is they're on. So definitionally, that will always be less than current turn. So instead, we can just get rid of this. And do it this way. So we'll get the ID. If the ID is less than the current turn, we add the ID. Or we return, we break out the loop, otherwise we add the current ID. So now we have the list of all enemies that are going to go on this particular tick. Then we need to iterate over them. So we're gonna make a unsafe list of type how would you store this? You want a list of each action for each agent. So we'll just make it a map. We'll do byte player ID to a unsafe list. Yeah. Unsafe list of action IDs. New. Oh, I need to name this. We'll name this valid actions. And then we'll set that. I don't think I have a size prepped for this yet. I mean, I guess we could set it to the number of enemies next tick dot length. There. Then what we're going to do is for int I is equal to 0, I is less than dot count, and then we're going to say for int action is equal to 0, action is less than bsd.valueRO dot archetypes dot archetypes bracket. This is going to be unsafe hash map. It'll be enemies next tick. Bracket I. Dot, we want their ID, so this is going to be or no, is it actions? That actions, there we go. Then we would need to iterate over valid number of directions. Have I stored that yet? If we go into archetype, action data. What is inside action data? No. Okay. Public enum direct or valid dirs colon byte. We're going to have oh, hold on. Flags. We're going to have the first one would be single target. Single no, what would you say? No target. This would be no target for the ability. Which would, no variation. Would that be how we word it? Equals 1. Non-diag is equal to 4. Can diag is equal to 8. And then aim is equal to 16. And then we would have, is there another one here? No variation, non-diagonal, can diagonal, and aim. The next one would be oh, I need to get rid of is empty. This does nothing in this context. Okay. Okay. Yeah, so I think that's the valid directions. Oh, wait, I skipped one. 1, 2, 4, 8. I was to say, something's wrong here. Action type? Can I do that and then make move equal 16, attack equal 32, cents equals 64. Yeah, so for spawn system, we're going to set this to equal action type dot move. And or equals oh wait, no, or equals is comparative. We need to do equals move or this was for the basic walk, I believe. So we also want this to be can diag, like that. And then this is an attack. I believe the attack we were trying to do a swing. So we'll set that to can diag as well. There we go. Okay. Oh, wait. I'm dumb. I'm very dumb. I'm fucking stupid. Oh. Yeah, this isn't a flag because I need to... Aim is going to be... fuck, I don't know. That gets really complicated what aim could be. Let's not worry about aim right now. We'll just... we'll change this back to action type. Here's what we'll do. Like a little switch statement. What the fuck? Switch name is going to be action type. Or no, it'll be bsd.valueRO.archetypes of enemy next tick bracket I dot actions bracket A. There. Case. First one is no variation. We'll just do if you want a new one, who ID is fuck, I am too out of it today. Hold on. Should I be doing this today? Oh, I don't know. I don't like this. Fuck me. Oh, this is irritating. I'm gonna go fucking kill this. No, I'm gonna listen. I'm gonna go like run or something or do something else and reset my brain and then come back to this. And then I'm gonna bash my head against something for an hour. Okay, I'll see what I come up with. I might stream tomorrow. I don't know. It's not fun to stream whenever you're like just fucking bashing your head against the wall trying to figure out how to actually do something. And I feel like I'm doing it in like the worst way possible. So give me a little bit, maybe I'll be back on.